Okay, we're back for part two, and I got to keep myself on the timer again. Hopefully this one won't be as long as the last one. And the theme for today, or for this lecture, are conversion factors. Now, if you remember in the last video, or the prior one, we said if anybody ever asks you, what's the definition of a conversion factor? There are examples when people say, well, 12 inches equals 1 foot. If you're a little familiar with the metric system, 1 inch equals 2.54 centimeters, or 1 mile equals 1.61 kilometers. But the truth is, from a verbal definition, and I would encourage you to write this one down, a conversion factor is a mathematical equality that equates two different units of measure. So basically, it's the same thing on both sides of the equal sign. And if you remember from the prior video, the reason that that is important is because when you take a conversion factor, like if you said A, and I'll put X as a unit here, equals B, and I'll use Y as the unit. When you put this into a magic H, so it looks like this, or if, because of the way you're doing things, you put it in the inverse fashion, both of these basically are the same thing as a value of 1. So you are not changing the concept of the number of the thing that you started with, but you are changing the units in which it is being expressed. And that's why, some people would say, well, the number changed. And the answer to that would be, yes, the number changed, but the units also changed. But because of that conversion factor concept, the value of the thing you're talking about, it is still exactly the same thing. Now, there are 3 categories of conversion factors that I want to highlight. And it's the last one where we have to do a little bit of work or practice. One type I refer to as English to English conversion factors. These are things that are like 1 foot equals 12 inches, or 16 ounces equals 1 pound. I'm trying to think from a liter perspective, or from a volume perspective, 1 gallon equals 4 quarts, etc., etc. Now, when you go, how do you know those? You can look a list of them up, but the bottom line is they have no regular way of being calculated. So those are just, in a sense, random numbers that if it's important for you to know them, you either have to write them down and have them handy on a piece of paper, or you just need to commit them to memory. Okay? Not very efficient, because that means if they create more of them, that's just more for you to remember. Now, the second category, most people who grow up in America, I don't think should have a problem with this. Although I am shocked, as I've run into in some classes, that there's a decent number of people who don't know there's 16 ounces in a pound. And if there was a place for you to go to get some exposure to different units, especially the English ones, go to the grocery store. You have all kinds of measurements in terms of a particular mass happening there on all the different things, all the different items there, because manufacturers are required to put the, we'll call them weights, technically they're masses, but the weights on all of their packages. Or, for that matter, in the case of fluids, the metric, the metric values as well. So if you've never done that before, they are all over the place. Now, a second category of conversion factors are what I call English metric conversion factors. Now these are ones that equate one English unit and a metric unit. Now again, there is no rhyme or reason to these numbers. These are just numbers that you would have to remember. But I mentioned one earlier. 1 inch equals 2.54 centimeters is an example of one. 1 gallon for volume things equals 3.78 liters. I'm trying to think of another one. Just 1 ounce equals 28.4 grams, and I'm just going to give you a dot on that one. Because again, when you ask how many of these are there can be quite a few. But one of the nice things is, for conversion purposes here in my class, you don't have to remember a huge number of them. There are different categories of conversion factors that we can break them up into. There is length, there is mass, and there is volume. Now we don't need to include like time there, because of the fact that time in the metric system is handled exactly like time in our English system, with seconds to minutes to hours, days, and so forth. I'm going to throw out the idea that if there was a metric time unit where they based all of the times on a day on a number 10, we would basically have to, it would be crazy. You would have to change that all over the world. It would be, if some people find it hard enough to go, what time zone are they in? Just think if another country had like a different system of measuring time. So the concept of 12 noon is some other number. We would be horribly screwed. So time, fortunately, globally, is all measured the same. So you don't need to necessarily remember conversion factors for time. And again, I say that because I'm assuming most people know 60 seconds in a minute, 60 minutes in an hour, 24 hours in a day, 365 days in a year, and so forth. Now, on the class web page, that website that I told you about, the Northgate Physics site, if you go to the conversion worksheets, one of the documents in there is a list of conversion factors. Now, there is way more on there than you need, but I would like you to go there and look at some of them, because my suggestion is that you choose a couple length ones, a couple mass ones, and one volume one that are English to metric conversion factors to be comfortable with. Usually, if you look at the length ones, there's usually things that are smaller that deal with feet and meters, and there are a couple that are longer that are like miles and kilometers. Just choose one of them. I've given you way more than you need, but that's just so that you're aware they're there. All right? Now, the last one that we are going to look at, and this is one where we're going to have to practice a little bit, is what I call a metric to metric conversion factor. Now, this is where you are going to do something. Now, the ones that people are familiar with are things like 1 meter equals 100 centimeters, okay? Or like 1,000 grams equals 1 kilogram. So the idea is that you're in a metric unit and you're staying in a metric unit. Now, the thing that I want you to become comfortable with is, what if you are taking two metric units that you're not really comfortable with, or they both have prefixes in front of them? So I am going to walk you through how to deal with that, and then I think the next class I'm going to show you guys a worksheet where you can practice some of this. Okay, so let me get rid of all of this. All right, and we can go ahead and say metric to metric. And I'm not really going to write the rules. I'm just going to do some samples, and I'm going to show you my methodology. And I'm going to tell you my methodology is based on a student that way back in the day when I first started teaching, I gave my class a decently long assignment of doing these. And this young man came back in like 2 minutes, and they were all perfect. And I asked him, Adam, what are you doing? And he took me through this system, and I'm like, how do you know to do this? And his answer was, my mom's a chemistry teacher. She taught me that. I'm like, damn it. Okay. But the system is flawless. Now, in order to do this, there is one thing you have to do with your metric prefixes. I look at my metric prefixes kind of like a chain of letters like this, and then I have nothing here for base, and then we have deci, centi, milli, micro, and nano. And I look at this like a number line. So this is 9, 6, 3, 2, 1, -1, -2, -3, -6, and -9. So if for some reason, because when you're saying, well, when are you going to have to do this? I don't know, okay? But this is more practice with metric prefixes. So if someone ever said, I need to know the relationship between a hectometer and a millimeter. The beauty, and we've mentioned this before, the beauty of the metric system, it is based on the number 10. So the idea here is that all metric to metric conversion factors have a 1 on one side and a power of 10 on the other side. So the challenge is figuring out, do I want to put 1 on a particular side or the other? And the truth is, you can actually do this both ways. But I am going to teach you a particular methodology so you always end up with a positive power of 10. So here is the deal. First of all, you need to determine between a hectometer and a millimeter, which one of these is bigger. If you remember this, all you have to remember is the one that's higher up is the one that's bigger. So that means a hectometer is the bigger unit. The bigger unit, I put a 1 in front of. And the other side is going to be a power of 10. Now remember, I don't use an actual 10. I use my capital E as a representation for 10 because it works on calculators. All right? Now the question is, what digit goes there? And this is where this is super simple. Hecto is in a position, if we pretend this is like a number line, of 2. Milli is here at -3. How far apart are those if we pretend this is a number line? And remember this guy here we're at 0. So this is like dealing with a number line. If you wanted to, you could just count them up, or you could do some quick math, and you could determine that they are 5 positions apart. That means this is a positive 5. Okay? So let's try another one. Now, I am not even going to put base units on here. I'm just going to do prefixes. So let's say that I have to equate let's use a mega something with a, let's see, let's do a, I already used hecto. Let's do a deci something. So if we look at these two here, which one of these is bigger? Mega is the one that's higher up. And therefore it gets the 1. And then when we look at where mega is at 6. Deci is at -1. And when we look at how far apart are those two, it's not adding the numbers, it's how far apart are they on a number line. The answer is 7. So 1 mega thing equals 10 to the 7th deci things. Okay, we'll do one more and then I'm going to call it quits because my time's up. Let's say we do 2 of them down here. So let's say we have a centi. I'll just use a triangle. A centi triangle, and we have to equate that with a micro triangle. Which one of these prefixes is bigger? Now sometimes people say, well, they're both on the small side. It's not about whether they're on the small or the big side. It is compared to each other, which one is bigger. And centi is the bigger one. And remember, that means it gets the 1 and the other side gets the power of 10. And then we look at this and say, centi's right here, micro is right there. How far apart are they? Don't worry about the plus and minus, because if we put 1 with the bigger unit, it's always going to be a positive number. They are 4 apart. So 1 centi thing equals 10 to the 4th micro things. This little scheme is bomb-proof, okay? But if you've never done it this way before, you just have to get used to it. This is the equivalent of the thing that I really don't like when people say, oh, you just need to move the decimal place over. I do not like that at all, because I want you to be able to explain to somebody why is it that you move that decimal place over. Now, I do want to point out one final note about this, and that is this guy right here. That 0 is our base unit. And the truth is that most of the time when you are setting up these equalities, one of the 2 units is going to be a base unit, so it actually will not have a prefix in front of it. It'll just be the unit itself. Just remember that you treat that as if it is at the origin, because the multiplier there is E0, or 10 to the 0 power. Okay, now I have a worksheet that I've put together that I will give to you at the next class where you can practice this. Okay, but this is everything about conversion factors. 2 of the categories you have to memorize. The other one, as long as you have this committed to memory and you understand the steps, which one's bigger? Put a 1 there, E on the other side, and then determine how far apart they are. And that's always a positive number on the power of 10. You're golden. And for those people who really like math, there is an opposite way you can do this so that your powers of 10 are negative, but I do not go there because I find that just ends up confusing people. Okay? So, giving you lots of conversion stuff. Hopefully next time in class, we're going to be able to actually start to structure some of this so I can give you a worksheet and say, try some of these problems and let's see if you can get them right. All right? Thanks for hanging in there, and see ya in class.